How can you measure a shadow's speed? Have you ever noticed how shadows seem to dance and shift as the sun moves across the sky? This fascinating phenomenon is not just a simple trick of light. It introduces us to the intriguing concept of shadow speed. Shadow speed refers to the rate at which a shadow moves across a surface, and it can vary dramatically depending on the position of the light source and the object casting the shadow. Understanding shadow speed is essential in the realm of physics, as it challenges our intuitive notions of speed and motion. Imagine standing outside on a sunny day, watching a tree's shadow stretch and shrink as the sun rises and sets. You might think that the shadow moves at a leisurely pace, but in reality, it can travel at astonishing speeds, especially when the light source is low on the horizon. This is where shadow speed becomes significant. It allows us to explore the relationship between light, motion, and perception, revealing how our everyday experiences can sometimes defy our expectations. Exploring shadow speed not only deepens our understanding of light, but also invites us to question how we perceive movement in our daily lives. For instance, when you wave your hand, the shadow it casts can move faster than your hand itself, creating a captivating visual illusion. This paradox challenges our intuitive grasp of speed and motion, prompting us to think critically about the nature of light and shadows. By delving into the concept of shadow speed, we can uncover the hidden complexities of the world around us. It encourages us to look beyond the surface and appreciate the intricate dance of light and shadow that shapes our experiences. So, the next time you see a shadow, take a moment to consider the speed at which it moves and the fascinating physics behind it. Understanding shadows. Shadows are intriguing phenomena that we encounter daily, yet their nature is often taken for granted. At its core, a shadow is a dark area or shape produced when an object blocks light from a source. This simple definition opens the door to a deeper understanding of how shadows are formed and the fascinating interplay between light and objects. The creation of a shadow begins with a light source, which can be anything from the sun to a lamp. When light travels in straight lines and encounters an opaque object, it cannot pass through, resulting in a shadow on the surface behind the object. The size and shape of this shadow are influenced by several factors, including the distance between the light source, the object, and the surface where the shadow is cast. For instance, when the light source is closer to the object, the shadow appears larger and more defined. Conversely, as the light source moves further away, the shadow shrinks and can become more diffuse. Another critical factor in shadow formation is the angle of the light source. When the sun is low on the horizon, shadows stretch long and dramatic, while overhead, sunlight creates shorter, more compact shadows. This dynamic relationship between the light source and the object not only affects the size and shape of shadows, but also introduces a fascinating aspect of perspective. Different types of light sources also play a significant role in shadow dynamics. A point light source, like a candle, creates sharp, well-defined shadows, while a diffused light source, such as a cloudy sky, produces softer, less distinct shadows. Understanding these nuances helps us appreciate the complexity of shadows and their role in our visual world. By exploring the nature of shadows, we can gain insights into the fundamental principles of light and how they shape our perception of reality. The physics of light. Light is a fascinating entity that plays a crucial role in our understanding of the world around us. One of its most remarkable properties is its speed, which is approximately 299,792 kilometers per second in a vacuum. This incredible speed has significant implications for how shadows move and behave. When an object blocks light, the resulting shadow is not static. It can shift and change rapidly, influenced by the speed at which light travels and the dynamics of the light source. Different light sources, such as sunlight and artificial light, can dramatically affect the characteristics of shadows. Sunlight, being a powerful and direct source, creates sharp, well-defined shadows, especially when the sun is high in the sky. In contrast, artificial light sources, like fluorescent or incandescent bulbs, often produce softer shadows due to their diffused nature. The intensity and quality of the light can alter not only the clarity of the shadow, but also its perceived speed as it moves across a surface. Another critical factor in understanding shadow speed is the angle of incidence, which refers to the angle at which light strikes an object. When light hits an object at a steep angle, the resulting shadow is elongated and can appear to move more quickly across the ground as the light source shifts. Conversely, when the light source is directly overhead, shadows are shorter and may seem to move more slowly. This interplay between the angle of incidence and shadow length adds another layer of complexity to our understanding of shadow dynamics. By delving into the physics of light, we can better appreciate how its properties influence shadow speed and movement. This exploration not only enhances our understanding of shadows, but also invites us to consider the broader implications of light in our everyday lives, from the way we perceive objects to the intricate dance of light and shadow that surrounds us. Measuring shadow speed. Measuring the speed of a shadow may sound like a daunting task, but it can be both fun and educational, with a few practical experiments. One simple method involves using a stick or a tall object to cast a shadow on the ground. By marking the position of the shadow at regular intervals as the light source moves, like the sun or a flashlight, you can track how far the shadow travels over a set period. For instance, you could measure the distance the shadow moves in 1 minute and then calculate the speed by dividing that distance by the time taken. To delve deeper into the mathematics of shadow speed, you can use the formula speed equals distance divided by time. If your shadow moves 2 meters in 10 seconds, the speed would be 0.2 meters per second. This straightforward calculation allows you to quantify the shadow's movement and understand the relationship between time, distance, and speed. Real-world applications of measuring shadow speed extend beyond simple experiments. In fields like architecture and urban planning, understanding shadow dynamics is crucial for designing buildings that maximize natural light while minimizing unwanted shadows. Similarly, in photography and cinematography, knowing how shadows move can help professionals create visually compelling images by controlling lighting and shadow effects. Moreover, in the realm of physics and astronomy, measuring shadow speed can provide insights into the behavior of celestial bodies. For example, during solar eclipses, the speed of the shadow cast by the moon on Earth can be calculated to understand the dynamics of the event better. By engaging in these experiments and calculations, viewers can not only grasp the concept of shadow speed, but also appreciate its significance across various fields. This exploration encourages curiosity and a deeper understanding of the interplay between light and shadow in our everyday lives. Curiosity-driven exploration. Shadows are more than just dark shapes cast by objects. They hold a treasure trove of surprising revelations that can spark curiosity and inspire deeper exploration into the world of physics. For instance, did you know that shadows can actually change shape and size depending on the time of day? As the sun moves across the sky, shadows elongate in the morning and evening, creating dramatic silhouettes, while they shrink to their shortest form at noon. This daily dance of shadows is a perfect example of how light and perspective interact in our environment. Another fascinating phenomenon is the concept of penumbra and umbra. When an object blocks a light source, it creates not just a shadow, but a gradient of light and darkness. The umbra is the darkest part of the shadow, where the light is completely blocked. while the penumbra is the lighter, outer region where some light still reaches. This distinction can be observed during solar eclipses, where the moon casts a shadow on Earth, creating areas of total and partial darkness. Such events encourage viewers to think critically about their observations and the science behind them. Moreover, shadows can reveal deeper insights into physics, particularly in understanding concepts like light propagation and wave behavior. For example, the way shadows behave can help illustrate principles of optics, such as diffraction and refraction. When light passes through different mediums, it can bend and create unexpected shadow patterns, prompting us to question how light interacts with various materials. By engaging with these surprising facts and phenomena, viewers are encouraged to observe shadows in their daily lives with a new perspective. What do the shadows around you reveal about the light sources nearby? How do they change throughout the day? This curiosity-driven exploration not only enhances our understanding of shadows, but also invites us to appreciate the intricate relationship between light and the physical world. Conclusion. As we wrap up our exploration of shadow speed and its fascinating relationship with light, it's essential to recap the key concepts we've discussed. We began by defining shadow speed as the rate at which a shadow moves across a surface, influenced by factors such as the distance and angle of the light source. We learned that the speed of light plays a crucial role in how shadows behave, with different light sources creating varying shadow dynamics. Additionally, we explored practical methods to measure shadow speed and the real-world applications of this knowledge in fields like architecture, photography, and even astronomy. Throughout our journey, we emphasized the importance of curiosity in understanding everyday phenomena. Shadows are not just simple dark shapes, they are windows into the principles of physics that govern our world. By observing and questioning the behavior of shadows, we can gain deeper insights into the nature of light and motion, enriching our understanding of the environment around us. Now, we invite you to engage with this content further. If you found this exploration of shadow speed intriguing, consider subscribing to our channel for more engaging videos that delve into the wonders of science and everyday phenomena. Your support helps us create more content that sparks curiosity and encourages learning. Don't forget to like this video if you enjoyed it, and share it with friends and family who might also be interested in the captivating world of shadows and light. Together, we can foster a community of curious minds eager to explore the science that shapes our lives. Thank you for joining us on this journey.